Week 1, lesson 12. Let's start with this example. Given this vector, let's find a vector that is perpendicular. All right, now we've been talking about directions and stuff. So if you think about this one being to the right, white is not the best choice here, Melinda. 1, 2, 3 to the right, and 1, 2, 3, 4, 5 down. That means that this has a slope of negative 5/3. All right, which means that the perpendicular slope should be positive 3/5. So let me start anywhere, right? Doesn't matter where. And a slope of 3/5. So up 1, 2, 3, 1, 2, 3, 4, 5. That would be the perpendicular. All right. Now, naming this vector, right? So name the vector perpendicular. This would be 5i plus 3j, or 5, 3. Okay. Which again, if you remember this original vector was 3, negative 5. There is kind of a cool coordination there between the original vector and the perpendicular vector. All right, so now on the screen, you're seeing some forms of lines that you've already used, you hopefully are comfortable with. They shouldn't be new to you. Something I just want to make sure I point out on standard form. This one's kind of important. There are some conditions on standard form, right? A, B, and C cannot be fractions or decimals, and this leading coefficient has to be positive. All right, so again, just a reminder. The new one that you're learning today is vector form of a line, which I know it looks really, really weird, but it's not that different from slope-intercept form. If you think about slope-intercept form, this letter represents a starting point, right? Like when you go to graph that, that's on the y-axis. This right here represents a starting point. It's a starting, literally, location on a graph. Okay, and in slope-intercept form, there is this M, which is sort of a direction. It tells you where to go. It tells you the rise over the run. And this vector is a direction vector. Okay, so vector form of a line is really very, very similar to slope-intercept form. Okay, so let's take a look at this first example. And it says, go ahead and write a vector equation, which means you need two things. You need a starting point. So I've got two. It really doesn't matter which one I pick. I'm going to pick this one. So let me start my vector equation. I'm not sure why that looks so bad. X, Y equals. So my starting point is negative 5, 3, right? That is an X and a Y. It's an actual spot where I'm starting from. Plus K times. Now I need a direction vector. Well, if I have a vector drawn from A to B, I can come up with a direction vector, right? The change up top of how much the X is changing is negative 7. And how much the Y is changing from 5 to 3 is negative 2. All right, now if you take a look down here, based on the last example, right, the one I just did, could these two things be this? Oh, well, look at that. This one actually is the exact same answer. But what if those negatives weren't there? What if I covered them up, right? What if that was the problem instead? Does that still count? Is that equivalent? And it is. Again, if you think about going to the right, oh, hold on, I'm still in white. Here we go. The right 7 and up 2, that's the same thing as going left 7 and down 2. All right, and the only difference between these two is this is a different starting point, but that's okay. Up here, you just need a starting point and a direction. Okay, so let me scoot this up a little bit. So you've now kind of learned vector form. Okay, from vector form, you can easily move on to parametric form. Okay, parametric form is where you have each of them sort of individual. So this would be one line, and then this would be another. So let me just write those out. So parametric form would look like this. X is equal to some number plus k times whatever the difference, direction is. And y would be equal to some starting point plus k times a direction. Okay, so this is considered parametric form. And then if you solve each of these for k, all right, that's what, sorry about that. That's what this is saying to do, solve for k. So on this one, k would equal, let's see, x minus x sub 1 divided by d sub 1. And on this one, k would equal y minus y sub 1 over d sub 2. So if this equals k and that equals k, then those two things equal each other. Sorry, that's okay. All right, now this part, I'm going to highlight this. I'm probably going to put a big old star around it. This is so unbelievably important. You will be given some equations that you're going to think are in Cartesian form, but the order really matters. All right, meaning you have to have the x or the y or the z, whatever one we're talking about. It has to come first. So even though algebraically these two expressions are the same, algebraically they are, in Cartesian form, if you're given this, you're going to be required to change it into this first, or you end up with negative errors, and it's just sort of a mess. All right, so let me scoot this up and take a look at this example. Okay, so they tell you that you have a line that's going through these two ordered pairs. And then they want you to find, and again, you can read 5 different forms of the same line. Okay, so let's start first with finding a direction vector. All right, from A to B, right? That's going to be our direction vector. All right, and if you remember, to find a vector from A to B, you just do head minus tail. In this case, the B minus the A. So B minus A is -3. And the B minus the A is 5. All right. So then, and I want you to, okay, sorry, I'm having a random thought. I want you to recognize that that is actually the same thing as this. Right? Just think about like what you know about graphing lines, right? If I said, hey, the slope is -3/4, right? Let's say we started at this point and you wanted to do a slope of -3/4. You could either go up 3 and to the left 4, or you could go down 3 and to the right 4, right? The location of the negative doesn't matter as long as there's only one of them. So I'm going to use this one, and I'm going to be honest with you guys. The reason I want to use that one is I have my notes sitting here right next to me, and I did it with my numbers there, and I don't want to make any mistakes. So that's why I'm going to use this as my direction vector. Okay, so here we go. Let's do part A. Let's find the equation in vector form. So vector form looks like this. I need a starting point. Again, you can pick either one, either the -1, 2, or the 2, -3, does not matter, plus k times the direction vector. Okay, so that's vector form. Okay, and I may not do these in order, all right, because if I just look at these two lines, that one and this one, as being two separate equations, and I write them up, right? X equals -1 plus 3k and y equals 2 minus 5k. Now I've got parametric form. So this is the answer to D, parametric. Yes, I put a T in there. It's in there. It's not misspelled. All right, now if I solve these for k, right? If I solve these for k, so let's see, x plus 1/3, that equals k. And y minus 2 divided by -5, that equals k. The second that I put those two things equal to each other, this is Cartesian form. Okay, Cartesian, which in this direction is part B. So I've got A, I've got D, I've got B. I'm only missing C and E. All right, so let's see. What should I do next? Oh, check this out. This is kind of cool. If I, and again, this is all algebraic manipulation. If I just cross multiply, I probably can get this thing into slope-intercept form. Or no, actually standard form. Let's do standard. Cross multiplying, I get negative 5x minus 5 equal to 3y minus 6. All right, I'm going to move everything to the right-hand side as far as letters, right? I'll have 5x plus 3y. And if I move that 6 to the other side, I get 1. I think that's a 1. Why is that a positive 6 on my notes? That should be a plus 2. Why do I, right here. No. Okay, I have a mistake on my notes. I'm doing it right on the paper. Okay, sorry guys. So this is standard. And moving it up just a little. The last one they wanted was slope-intercept, which is part C. Part C. If I just take this and isolate the y, so 1 minus 5x equals 3y, and divide by 3, I have slope-intercept form. I've got what? Negative 5/3 x plus 1/3. Slope-intercept form. There you go.